Okay, so we're back and we'll be taking questions that will be dealing with linear equations using indices. Now, this is what we're doing formally, so I'll wipe this board off. Or let me take the screen out of our way, and let's start with a fresh new screen. Okay, so let's take a question and we'll dive right into it. Remember, if it's the unknown is a power, then write everything in a common base. If the base is the unknown, then please try to eliminate the power that the base carries. Is that okay? So I'm just doing a recap on what we did last time. Okay, so let's take a question. Now, I'm looking for a good one to try out. Okay, I think I found two good ones. Let's take this. 9 times 3 raised to the power of 1 plus x is equal to 27 raised to the power of minus x. Find the value of x. Remember I told you that in a linear equation you have only just one unknown, so that's why we're having only just x here. There's no x and y. When it's x and y, then it's a simultaneous equation. Remember, when it's x, y, and z, is a what? Cubic equation. When it's x, y, z, another one maybe a, it's what? I think it's called, I've forgotten that one. Maybe later on I'll check for it. But I know it's not enter into a polynomial equation, something like that. Something of that nature. But let me not say something that I'm not very sure. So please let's do that. Okay, so let's take this question down. Now we've taken the question out and let's start solving it. Remember, our unknown is what? The power. So what did I say when the unknown is the power? You do what? Write the base. Right? Make sure you write it in a common base. So look at this. Is there any common base you can find here? Yes. What's the common aspect of the base? 9 can be written in the base of 3. 27 can be written in the base of 3. So what are we waiting for? Write it. I remember when I was still young, when I was in school. Okay, let me not gist you yet. Maybe I'll gist you at the end of the class. Okay, so for 9 we have 3 raised to the power of 2 will give you 9 times 3 raised to the power of 1 plus x still remaining, still there. And then for 27 we have 3 raised to the power of 3 brackets minus x, right? That's good and fine. So next, 3 raised to the power of 2 multiplying 3 raised to the power of 1 plus x. We apply the law of indices. What law is that? Addition law. I had to pause to be sure you guys have thought it out through. Okay, so addition law tells us to take one of the bases and then it becomes 2 plus 1 plus x. Notice something, I had to put it in a brackets because I want to tell you that the plus is opening these brackets. I know why I'm saying it too, as in Nigerian slangs they will say it gets y. Okay, so 3 multiplying minus x, whatever is in the product law, what the power outside the bracket to multiply the power inside. So 3 times minus x will be minus 3x. And then let's add this up. We have 3 raised to the power of what? 2. When plus opens this bracket, is like just saying 2 plus 1 plus x. So we can add them up. 2 plus 1 is 3 plus x. Since they are unlike terms, they can't add. Okay, so what's the next thing we have here? Since their bases are the same and there's an equality sign here, you can take away the bases. So you can just take away this base. This base now disappears. And we begin to work with the what? The index. So taking away this base, I can write take away bases. So, or base. So taking this away, we have 3 plus x as the index and minus 3x. So we continue our solving, and in solving this we take like terms. So let x's go this way, so that will be okay. Let this one come this way and this one go the other way. So it will be x plus 3x because minus 3x came over here and then 3 went over this other way, so it will be minus 3. I'm trying to make my unknown to be at the left hand side because it's always good whenever you're ending your mathematical work, your unknowns are always the ones at the left hand side. I believe you know that already, or if you don't know that now. So x plus 3x is 4x is equal to minus 3, and I know you can see that x is equal to what? Minus 3 over 4. And Gabadaya, we are done. Okay, so let's take another question. So the answer is minus 3 over 4. Another question here, I can see this one. This one, I think it was quite tough. I saw it in the JAMB question, then finally came out in WAEC, one of those WAEC questions of those days. I can't remember the year. I think it's 1997 so I came out. So let's try to work this out. 64 over 27 brackets is equal to 3 over 4. Okay, there's actually no bracket for that 64 over 27. Okay, so let me just take away the brackets, though it doesn't really still mean anything whether it's there or not, but let's just take it away so we'll have what they give us. So find t. Okay, so in finding this, remember we have to look for the common base, right? Now notice something. Is there a common base here? Check it out. Look. 27 can be written in the base of 3, right? So we can see that 27 and 3, they have a common base. Okay, we found that one out. What about 64 and 4? Yes, 4 can be written. 4 is a common base of also 64, because 64 can be written in 4 raised power what? 4 raised power 3. 27 can be written in what? 3 raised power 3. And it's something, these and these are common base, these and these are common base. So our job is to do what? Write everything in their common base. Okay, that's if you're looking for the unknown as a power. So we come down here and then we write them in their common base. So 64 will be what? 4 raised to the power of 3, and 27 is what? 3 raised to the power of 3 is equal to 3 over 4 bracket t minus 1. So what do we do here now? Let me put this in a bracket. So since their powers are the same, I can just pick one of the power, 4 over 3, put it all in a bracket and put it this way, and then 3 over 4 t minus 1, right? So this is it here now. So what's the next thing? Notice something. Here is 4 over 3. Here is 3 over 4. So I cannot really eliminate this base like how I did this particular. Look at this one here. I took away the base because it is just 3 and 3. So I can take away the base since they are alike. Since this and this are alike, I could just take away the base. But look at this one here. This and this are not alike. They are looking alike, small but not very well. Because 4 over 3 is not the same thing with 3 over 4. Is that not so? But wait. Can we transform one of them to look alike? Yes, we can. By doing what? Remember, how do you transform something? I remember I told you in one of the classes, I showed you about a law called the negative index law. I think that was the 4th law we learned, negative law or negative index law. And I told you that if you have an x to the power minus 1, you can write as what? 1 over x. But what if you now had, I showed you that, what if you now had, let's say, an x over y, and then it is equal to minus 1. I told you that this can be flipped to be what? Y over x. Is that not so? I remember I said something like this. But actually, I showed you that if you had a 3 ladder, that's a 3 fractional ladder, something like this, x over y over z. I told you that this z can come up. Or if it was 1 over x over y, this y can come up. And if it was in this case, the z will multiply x, it will now be xz, it will be xz is equal over y. Y for this case to be what? 1 times y is just y over x. So everything I've just shown here, we'll work with it. So please let me wipe this off. So I think I should just use okay, so did that go out? Yep, I think that went out, and that's out. Okay, so let's continue, please. Now what can we do here? We can apply the negative index law to either one of these, either this or this, to flip it. So if I apply it here, it means I will flip this one. If I apply it here, it means I will flip this one. But remember what I told you, that whenever you're applying anything, it's like your reaction in chemistry. Whatever you do to the reaction, you must also do to the reactant. Remember that. Always remember that in mathematics, your equation must be balanced. Whenever you're bringing any new thing, whether be it a number, a sign, whenever you are bringing any new thing, whatever I do to the left hand side, please remember to do to the right hand side the same way. I remember I said sides, I didn't say numbers, I said sides, because we're working with the sides entirely, not just with the numbers. So I come here and I say, please, I want to apply my negative index law. So I say applying, okay, let me not say applying, let me write let me say I want to raise them to power 1. So let me raise to negative 1. So let's say power minus 1 for both sides. So now raising them to power minus 1 for both sides to be what? I say 4 over 3 minus 3. That's, I'm not going to multiply it now by minus 1, and then 3 over 4, and then here will be what? because see here is t minus 1. Remember I multiplied everything by minus 1, so let me just use this. Let me leave the minus 1 still outside. So sorry, that's very wrong way of writing it. Let me put that very well. So that will be minus 1 multiplying t minus 1. Let me give a space. Well, okay, so I think that's better because I multiplied everything by minus. I say raised to power minus 1. So here 3 multiply minus 1, that's minus 3, and then minus 1 multiply this. So we've not opened that part yet. Okay, now let's continue. So please, my screen move this way, and let's continue. So I have this to continue with. Let me use my green biro. I think I'm loving green now. So having this, when you have minus 3, remember once you have the minus sign, you can just flip this, so it becomes 3 over 4 brackets minus, sorry, the minus is now off, so bracket what, 3 is equal to 3 over 4 brackets. Now when I use minus sign to open this bracket, I have what, I have 1 plus 1 minus t. I have 1 minus t. I believe you know how I did that. When you have minus 1 opening t minus 1, to be minus 1 times t is minus t, minus 1 times minus 1 is plus 1, because minus times minus will give you plus. But I can rewrite this from the positive to the negative, it becomes 1 minus t, right? That I did here. So now we continue. Remember, we continue now. So in this part, now look at it now, they are alike. So because of they are alike, I can now do what? Remove bases or base. So now I can remove my base and I'm back. 3 is equal to 1 minus t, and I can solve for my 3. 1 can, so my 1 can come over here, and I have 3 minus 1 is equal to minus t. 3 minus 1 is what? 2 is equal to minus t, and you can now, since you have a minus sign, to take away the minus sign, you can either multiply by minus 1 or divide by minus 1. So let me just do whichever one of them. So I can just say divide by minus 1 and we have 2 over minus 1 is equal to minus t over minus 1, and this cancel this, so t divided by minus 1 gives us that t is equal to minus 2, and we are done. Question? Drop it. Though I don't think you have any question here. So that's how to solve it. So I think I've solved 2 very sweet questions. So in case you have more questions again for me to solve or for us to tackle that you've tried out, it's confusing, drop it for me. Oh, I'm forgetting one thing. Now I'll just give you a scenario, something like that might happen, but I'm not going to solve any much questions here. What if they gave me a question like this? Let's say okay, this is a very simple question. I'll just craft it out immediately. Avatar mode. I love that film Avatar. When I was younger, I watched it a lot. So now see a very simple question. If they give something like this, 27 raised to the power of x is equal to 1. How do you solve for a question like this? It's looking very tough because there's no alike base, right? There's no base that is alike. Is that not so? Yes, that's so. But how do you solve for it? Let me show you how. Remember, in that law I told you, first of all, I can write 27 in a base, right? I can write 27 in the base of what? 3. Or I can even just leave as 27 like that. It doesn't matter. But remember, there's a law I told you of. The law called the zero index law. The zero index law tells you that every number reached power 0 will give you what? 1. Any number. Remember. Therefore, I can just write this one as what? 27 raised power x is equal to 27 raised power 0. Because 27 raised power 0 will give me what? 1. Remember that. Therefore, so I can represent my 1 as what? 27 raised power 0. And then, what happens? I am back to work. So, being back to work means that I can just say remove my basis and I have my x is equal to what? 0. And that is good. Is that not so? But I just did a very short case. There's a time when they'll give you a longer question where you have to bring in something like this, or you have to manipulate it in that way. But if you can remember this, it will help your life a lot. Okay, so that's it for this particular question. So I'll look for more other questions. Maybe I'll do one more video questions. Then we'll enter into this working in simultaneous equations, simultaneous linear equations for indices, and that's where we'll wrap it up for our initial class. Thank you.